Discover how massive pipeline projects worldwide are installed using advanced technology that drives global water, gas, and energy connections. The installation of glass-reinforced plastic pipes in open trenches requires careful handling, preparation, and alignment to ensure a leak-tight and long-lasting system. The contractors in this project used flow-tight gray pipes with a pressure rating of 32 bars, 600 millimeters diameter, and stiffness of 10,000. To adapt to the steep terrain, a combination of 6 meters and 12 meters pipes was selected to achieve the necessary curvature. Receiving and storing pipes on site. When receiving the pipes, they must be placed on stable and level ground. If the ground is uneven or hard, wooden supports should be used to prevent damage and make future lifting easier. Only undamaged pipes should be installed. During handling, always use 2 certified lifting slings and never use steel cables or chains directly on the pipe. For guidance and control during lifting, a rope can be attached to one end. Flow-tight pipes are UV resistant and can be stored outdoors for long periods if stored according to the manufacturer's guidelines. Excavation and bedding preparation. To open a new trench, the topsoil is first excavated and the soil is stored a safe distance away for later backfilling. The bottom of the trench must be stable and leveled, which can be checked using a pipe laser. For this DN 632 bar pipeline, the maximum allowable angular deflection is 1 degree. Therefore, the combination of pipe lengths helps accommodate curves. Bedding material of 100 to 150 millimeters thickness is placed at the trench bottom, ensuring the pipe barrel rests evenly while the coupling sits in a slightly deeper hole to prevent load on it. Lifting, joining, and sealing pipes. Pipes are lifted using 2 slings and guided with a rope. Before joining, the grooves and rubber gaskets are cleaned using water and a brush. A suitable lubricant, never petroleum-based, is applied to both the gasket and spigot. During assembly, the pipes must be aligned accurately and pushed slowly until the spigot reaches the home line. For tight pressure couplings, come-along jacks may be used to ease insertion. To confirm proper gasket positioning, a feeler gauge is slid between the pipe and coupling. If the gauge does not encounter the gasket all around, the pipe must be disassembled and reinstalled. Correct gasket placement ensures a durable, leak-proof connection. Backfilling and compaction backfilling begins immediately after jointing to secure the pipes. Only native or imported non-organic soils should be used, free from frozen or harmful materials. Oversized particles are removed using a grid, maximum 50 millimeters spacing for DN 600 pipes. The contractor in this project used granular native soil, which compacts easily. Soil is placed around and beneath the pipe barrel, forming proper haunching. Additional soil layers, 100 to 300 millimeters thick, are added and compacted with a vibratory plate after each lift. Care is taken to prevent oval deformation of the pipe. Finally, the pipe crown is covered with at least 300 millimeters of compacted backfill. The trench is refilled with the remaining excavated soil, and the topsoil is restored. The GRP pipeline installation is now complete and ready for long-term service. The process of bending large-diameter steel pipes used in long-distance pipeline construction. This bending operation is essential to allow the pipeline to follow the natural terrain without excessive stress or welding. The process is performed using a hydraulic pipe bending machine, also called a cold bending machine, because it bends the pipe without heating. First, the pipe is placed on the ground near the bending area. A strong rope is tied tightly around the middle of the pipe. A digger is then used to lift and guide the pipe, ensuring it is properly aligned with the bender. The bender itself is a large, heavy-duty piece of equipment consisting of a central bending die and multiple hydraulic clamps that hold the pipe in place. Once the pipe is correctly positioned, the operator adjusts the control system of the machine to set the desired bending angle and radius. The machine then applies gradual hydraulic pressure through its bending shoe, forcing the pipe to curve smoothly while avoiding deformation or wrinkling. During the process, the operator constantly checks the pipe's shape and angle using measuring instruments or templates to ensure accuracy. This cold bending method allows for bending angles up to several degrees over long pipe sections, typically used in cross-country oil and gas pipelines. Because no heating is involved, the mechanical properties of the pipe, such as strength and toughness, remain unchanged. After bending, the pipe is carefully removed from the machine with the help of the excavator and placed on wooden supports or rollers to prevent surface damage. In summary, bending pipes with a hydraulic cold bending machine is a precise and efficient technique widely used in pipeline construction. It combines mechanical control, careful handling, and continuous monitoring to produce high-quality bends that meet strict engineering requirements, ensuring the safe and smooth routing of pipelines through varied terrain. The Literoll XWay system is an advanced and innovative technology specifically developed for the installation of pipelines across steep and complex terrains. Created by Literoll, a Brazilian engineering company well known for its technological solutions for the energy sector, the XWay system is designed to make pipeline construction possible even on slopes ranging from 5 degrees to 90 degrees. This level of adaptability enables engineers to install pipelines safely and efficiently in mountainous regions, hilly landscapes, or areas with difficult access where conventional methods are not feasible. The XWay technology operates through a mechanical platform equipped with a series of rollers, anchors, and controlled movement mechanisms that guide the pipeline along the desired route. The system ensures precise control of positioning, speed, and angle, preventing slippage or misalignment during the laying process. It significantly reduces manual intervention and enhances the overall safety of the operation. By stabilizing the pipeline during descent or ascent, it minimizes both the physical effort of workers and the environmental disruption usually associated with traditional pipeline construction methods. According to Petra Noticias, the XWay system represents a major breakthrough in the global pipeline industry. Its modular structure allows easy transportation, quick assembly, and adaptability to different types of terrain. Moreover, it helps lower project costs by reducing the need for large excavation works or complex support frameworks. This approach not only shortens construction time, but also preserves the surrounding environment. The system has been successfully used in several oil, gas, and energy infrastructure projects, especially in locations with extreme topographical challenges. By combining mechanical precision with engineering innovation, Leaderroll's XWay system has set a new standard for modern pipeline construction. It perfectly demonstrates how advanced technology can overcome natural obstacles, ensuring both efficiency and sustainability in demanding engineering operations. The RC25 vacuum lifting system from VacuWorks offers a heavy-duty 25-ton lifting capacity, making it ideal for large-diameter pipe and infrastructure tasks. On a major U.S. project, logistics specialist Jones Logistics deployed the RC25 to handle single pipes weighing 547 pounds, demonstrating its practical capability in real-world pipeline operations. Equipped with vacuum pads that grip the surface of coated pipe, 360 degrees rotation for precise placement, and wireless remote operation to reduce reliance on slings and chains, this system enhances safety, speed, and accuracy in lifting. Whether used at a spool yard or on a field turnout, the RC25 is a reliable solution for demanding material handling applications. Welders performing automatic GMAW on a 30-inch outer diameter cross-country pipeline. GMAW, also known as MIG welding, is a process that uses an electric arc between a continuously fed wire electrode and the base metal to generate the heat required for fusion. The wire electrode, supplied from a spool, acts as both the current carrier and filler metal, feeding steadily through the welding gun into the weld pool. At the same time, a shielding gas such as argon, helium, or an argon carbon dioxide mixture is directed through the gun to protect the molten weld pool from atmospheric contamination. During the process, the arc heat melts both the wire and the base metal, and upon cooling, a strong uniform joint is formed. This automatic GMAW system ensures high productivity, consistent weld quality, and reduced operator fatigue during long pipeline welding operations. The Rentis method, also known as the surface tow method, is an offshore pipeline installation technique where long pipeline sections are fabricated entirely onshore before being transported to their final location. This method offers an economical and efficient solution for laying subsea pipelines over long distances. First, the onshore fabrication phase involves assembling, welding, testing, and coating the pipeline string to ensure quality and integrity. Next, flotation devices or supports are attached to the completed pipeline to make it buoyant on the water surface. In the towing stage, powerful tugboats tow the floating pipeline along a predetermined route toward the offshore installation site. Once in position, the submergence phase begins. The pipeline is carefully lowered to the seabed through controlled flooding or the removal of flotation aids. This process requires precision to avoid overstressing or bending the pipe. After the pipeline reaches the seabed, positioning and connection operations are performed, often using specialized vessels to lift and connect end sections. The surface tow method is widely used because of its cost-effectiveness, adaptability to various pipe diameters, and reduced offshore welding work. However, it demands thorough planning to control forces during towing and submergence. This method is often combined with other installation techniques for tie-ins or complex subsea connections, making it a reliable solution for offshore pipeline projects. The Texum coring machine BR2800 HCSP is a heavy-duty industrial core drilling machine designed for creating large and precise holes in hard materials such as concrete. It features a self-supporting mobile HCSP station for easy relocation and operation. The machine offers hydraulic movements for the turntable, drilling height, and tower positioning. Its turntable accommodates products up to 2,800 millimeters in diameter, with a drilling height of 1,800 millimeters. The standard model provides a 3-step drilling speed and manual pressure control, while optional features include pneumatic core pushers, laser sensors for height measurement, and infinitely variable speed control, ensuring accuracy, efficiency, and flexibility in construction and infrastructure applications. The La Esperanza water pipeline project in Ecuador, undertaken by Odebrecht, is a large-scale infrastructure initiative designed to transport water from a major dam to the Refinería del Pacífico, one of the country's key industrial facilities. The project involves the installation of approximately 60 miles of 48-inch diameter steel pipelines, requiring high levels of precision, coordination, and advanced construction equipment. Worldwide Group played a crucial role by supplying a full range of specialized machinery and pipeline accessories for the project. This included hydraulic pipe layers for lifting and positioning large pipe sections, pipe benders for shaping the steel pipes according to the terrain, and pipe carriers for safe and efficient transportation. Welder tractors ensured continuous and high-quality welding of the pipeline joints, while powerful excavators were used for trenching and backfilling operations. The installation process began with surveying and trench preparation, followed by the delivery and alignment of the large pipe segments. Once in position, each section was welded, inspected, and coated for corrosion protection before being carefully lowered into the trench using hydraulic pipe layers. After placement, the pipeline was backfilled and compacted to ensure stability and long-term durability. This project demonstrates Odebrecht's capability to execute complex pipeline works in challenging environments, integrating advanced technology and heavy equipment support from worldwide group to ensure efficiency, safety, and environmental responsibility throughout the construction process. The Route 58 Rehabilitation Project in Southampton County, Virginia, introduces an innovative approach to road construction by replacing traditional asphalt overlays with hydraulic cement concrete pavement. The Virginia Department of Transportation, which has long relied on asphalt, is now testing this new alternative to reduce dependence on oil-based materials and mitigate the effects of fluctuating oil prices. In this project, a continuously reinforced concrete pavement is applied, eliminating the need for joints that typically cause the repetitive noise of conventional concrete roads. The embedded steel reinforcement keeps cracks tightly closed, ensuring a smoother and more durable surface for motorists. The construction process involves an unbonded concrete overlay technique. First, the existing pavement is shot blasted to remove oil, dirt, and debris, creating a rough surface for better adhesion. Fresh concrete is then delivered from the batching plant and spread evenly across 2 lanes using a paving machine. Subsequent equipment ensures proper compaction and uniform thickness. Finally, a curing compound is applied, and fine grooves are raked into the surface to improve traction and safely drain water from the roadway. Advanced GPS technology precisely guides the paving machines, ensuring accurate alignment and consistent pavement thickness. This efficient method not only provides a smoother ride, but also offers VDOT engineers a cost-effective and sustainable alternative for future projects. The Virginia Center for Transportation Innovation and Research will continue to monitor the performance of this new hydraulic cement concrete pavement to evaluate its long-term success. The Hobas hydropower system uses high-quality, low-friction pipes that improve turbine efficiency and reduce energy losses. With over 25 years of proven performance, Hobas offers excellent quality, reliability, and cost-effectiveness for modern hydropower installations. Hobas GRP pipes have been successfully installed in a wide range of demanding infrastructure projects across France, demonstrating their versatility and reliability. In Lille Metropole, Hobas pipes were used in the construction of a large storage tank and a pumping station in the old part of the city. This project significantly improved wastewater management and helped prevent urban flooding. In Béziers, Hobas provided durable GRP pipes for strengthening and securing potable water pipelines. The installation involved pipe jacking beneath major roads RD11 and RD609, a railway track, and even the historic Canal du Midi. In Nice-Nord, the company supplied non-circular Hobas NC profiles to rehabilitate an aging main sewer in the densely populated city center, ensuring long-term performance and minimal disruption. Meanwhile, in Bouchain, Hobas pipes were installed for the cooling water system of a new combined cycle power plant, providing high corrosion resistance and excellent hydraulic efficiency. Beyond France, Hobas also contributed to the Deer Lake project in Newfoundland, Canada, where GRP penstock pipes replaced the existing system in a hydroelectric power plant. These projects illustrate Hobas's global reputation for quality, durability, and innovation in water infrastructure solutions. The UA Local 342 pipeline bore process represents a highly specialized underground construction method designed to install pipelines with minimal surface disruption. In this project, crews prepare the site by carefully aligning equipment and setting up the bore rig at the entry point. The process begins with the drilling of a pilot hole, which guides the path of the pipeline beneath the ground. This step requires precise control and constant monitoring to ensure accuracy, particularly when navigating beneath existing infrastructure or natural obstacles. As the bore advances, specialized tools and drilling fluids stabilize the hole, prevent collapse, and reduce friction. Once the pilot hole reaches the designated exit point, the crew enlarges the bore to the required diameter using reaming tools. This enlargement stage allows the pipeline to be pulled smoothly into position. The actual pulling of the pipeline is a critical phase, where heavy-duty machinery and skilled operators work together to ensure the pipe enters the ground without damage. This trenchless technique is not only efficient, but also environmentally considerate, reducing the need for open excavation. UA Local 342's expertise ensures that the pipeline bore process is executed safely, effectively, and to the highest industry standards. Steel Mains is Australia's largest manufacturer of steel water pipeline systems, with over 125 years of proven expertise. Operating across the country with advanced production lines, dedicated R&D, and industry-leading installation training, the company consistently meets the demands of large-scale, fast-track projects on time and within budget. Notable achievements include the Southeast Queensland water grid, with 334 kilometers of Sintecoat steel pipe, and the Sunwater Burdekin to Moranbah pipeline, delivering 5.5 kilometers of pipe per week. Other major projects include the Goldfield Superpipe, the Sugarloaf Pipeline, and the Victorian Desalination Project, featuring up to 1,930 millimeters diameter steel pipes. The Sintecoat corrosion protection coating, proven effective even after 35 years underground, ensures durability for over a century. Through innovation, logistics support, and precision manufacturing, Steel Mains delivers complete and reliable pipeline solutions nationwide. The Glebe Weir project in Queensland is the second pipeline of its kind, delivering up to 36,500 megaliters of treated coal seam gas water annually. Steel Mains manufactured and supplied 120 kilometers of large-diameter steel pipes, 940 to 1,400 millimeters, ensuring fast installation, superior durability, and on-time, on-budget delivery. The road construction process in Bluff City by Andale Construction begins with ripping before the injection of slurry, where the existing dirt road surface is mechanically broken up to loosen compacted soil and prepare it for stabilization. Once the surface is properly ripped, the next step is injecting slurry, a specially formulated mixture designed to bind with the soil and improve its load-bearing capacity. After the slurry is evenly distributed, the crew proceeds with mixing the material and slurry using specialized equipment to ensure thorough blending. This step guarantees that the stabilizing agents penetrate deeply and uniformly throughout the base layer. Once the mixing is complete, compacting with a pad foot roller follows immediately. This type of roller provides deep compaction, removing air pockets and ensuring a dense, stable subgrade. The next operation is finish blading and flat rolling, where the surface is carefully leveled and smoothed using motor graders and smooth drum rollers to achieve the desired shape and grade. Afterward, density testing is performed to verify that the compaction meets the required engineering standards, ensuring the foundation's strength and durability. Subsequently, microcracking is carried out to release residual stresses in the stabilized layer, preventing future reflective cracking in the asphalt pavement. Once the base is fully prepared, asphalt is being paved, forming the primary roadway surface that provides structural integrity and smoothness for vehicles. To enhance durability and weather resistance, a HA5 high-density mineral bond is applied. The process involves applying the first coat of HA5, which penetrates the surface and seals micropores, followed by applying the finishing coat of HA5 to create a dense, protective layer. This final coating significantly extends the pavement's lifespan by protecting it from oxidation, water intrusion, and ultraviolet damage, resulting in a smooth, long-lasting road surface ideal for all pavement applications.